All right, folks, we're going to begin our curve sketching unit today. For starters, I'm going to review solving for x and y intercepts. We will learn how to sketch a rational function, but what we do is kind of piece by piece or day by day build up to that, making a complete sketch. So in the beginning, day one, we're just going to look at solving for x and y intercepts, and we're going to explore a concept called symmetry. So for starters, if I want to find the x-intercept of this function, I'm going to let y equal 0. So I'm going to take my equation, x squared minus x minus 6 divided by x plus 1, and I'm going to replace the y with a 0. Now the goal will be to solve for x. Okay? What I'm going to do first is multiply both sides by x plus 1. All right, that's going to leave 0 equal to x squared minus x minus 6. This x plus 1 will cancel that x plus 1. 0 times x plus 1 would be 0. Other people might put a 1 under the 0 and cross multiply. That's perfectly fine as well. Okay, when I get it here, I have a simple trinomial. I am looking for two numbers that add to give -1 and multiply to give -6. Those numbers would be -3 and +2. Okay, add to give the middle, multiply to give the constant term at the back. X minus 3 times x plus 2. And if I multiplied this out, x times x, I'd get x squared plus 2x minus 3x. There's minus 1x. -3 times 2 gives me -6. Zero product principle tells me that if this bracket times this bracket multiplies to give me an answer of 0, that either the first bracket must equal 0 or the second bracket must equal 0. Solving for x, I get x equals 3. Solving this for x, I get x equals -2. So this function actually has two x-intercepts. Notice how I write the point. X is -2, y was 0. X is 3, y is 0. X first, y second. So there's an x-intercept. For a y-intercept, I take the exact same equation, only this time I'm going to fill zeros in for x. Y-intercepts are much easier. All I'm going to do is straight order of operations, some direct substitution, and then use my order of operation. So 0 squared, that's 0, minus 0, still 0, minus 6, gives me -6. 0 plus 1 is 1. -6 divided by 1, -6. Now, when I write this as a point, I'm going to write x is 0, y is -6. And that is how you solve for an x-intercept and a y-intercept. All right? Don't forget that there's some factoring involved. If you have a rational function, okay, when we get into these later on, I'll say this again, but you can really just set the the numerator equal to 0 and solve for x. Notice after I cross-multiplied, or after I multiplied both sides by x plus 1, okay, I was left with the numerator equal to 0. Factoring will be important in this, so you're going to have to look back in your notes on all the types of factoring we've done: simple trinomials, hard trinomials, difference of squares, sum and difference of cubes, common factors, all right, synthetic substitution. All of those may come into play in question 1 from your worksheet. All right, the next thing we're going to talk about is something called symmetry. We've got even functions. They satisfy this, f at -x is equal to f at x. And we have odd functions that satisfy this, f at -x is equal to -1 times f of x. Even functions are symmetric about the y-axis. Okay? Odd functions are symmetric about the origin. 0, 0. All right, let's have a look at this. Okay? A function is even if it is unchanged when x is replaced by negative x. The graph of an even function is symmetric about the y-axis. So if I look at this point right here, looks like it's a little less than 2 to the right, and I'm up 1, 2, 3, 4, a little less than 5, let's say 4.6. So when f equals 1.8, or x equals 1.8, the height of that function is roughly 4.6. Same thing's true on this side, only I'm replacing the 1.8 with a negative 1.8, but the height is still the same. It's still 4.6. Okay? Therefore, we can say f at negative x, f at negative 1.8, is equal to f at x, f at 1.8. And that right there is classified as an even function. Okay? This function is even. A lot of times you can look to the exponents, all right? This would be an even function because both the exponents are even. That might be helpful as well. Notice the symmetry about the y-axis. Here it is. If I took this piece of the curve right here on the right and folded it across the y-axis, it would lay right on top of the left, or vice versa. If I folded this left piece across the y-axis, it would lay right on top of this. That is an even function. Now, note the difference between an even and an odd function. Let's talk about this point right here. Okay? Let's say 1.8 to the right. When x equals 1.8, y is 1, 2, 3. Or, yeah, just a little shade lower than 3. We'll say 2.9. Now watch this. If I go 1.8 units to the left, I end up down 2.9 units. So if I change that x value from a positive to a negative, my y value actually becomes a negative, or switches signs. That means that f at negative x, f at negative 1.8, is equal to negative 1 times f of x. There's my f of x value. When x is 1.8, I got a positive 2.9. F at negative x, I get a negative 2.9. And that means this function is odd. Okay? An example of an odd function, you might see something like this. X to the 7th plus x cubed. Odd exponents gives you an odd function. An odd function is symmetric about the origin. Now the origin is the point 0, 0, right here where the x and y axis meet. So think if I grabbed onto this point right here and I rotated it 180 degrees through the origin, this piece right here, if I rotated it this way, 180 degrees, it would lay right on top of this piece. That's the symmetry. And that is called an odd function. Okay, just a couple of extra questions. It says symmetry is used to reduce the amount of work in graphing. It says if we have graphed an even function for x values that are greater than or equal to 0, all the positive x values, we just reflect it in the y-axis to get the entire graph. So you could basically draw the right side of the curve and then just flip it across the y-axis, and that would give you the left side. Those are for even functions. If it's odd, you just rotate it 180 degrees through the origin. All right, here's the test. So I think on question 2, the bottom portion of your worksheet. What you're going to want to do is the test for an odd function or an even function is the same. This is f of x. Some people might notice the exponent's even. Okay, so this is going to produce an even function, but here's how I can tell. Here's how I can show that. Replace the x's with a negative x. And then work out the right-hand side. Okay, negative x to the power of 6 really means this. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6 negatives multiplied together gives me a positive. X times x times x times x times x times x would give me x to the 6th. F at negative x is equal to x to the 6th. Well, check this out. That's what f of x is equal to as well. So therefore, I can say that f at negative x equals f at positive x. That gives me an even function. If we look back to our notes, there it is. An even function satisfies f at negative x equal to f at positive x. All right. I'm going to erase that and get that piece out of the way. G at x. You might notice that. That's an odd function. If I flip that up, it would be like saying x to the negative 1, also odd. Fair to say that this is an odd function, no problem. Let's test. How do we test? We replace all the x's with negative x. So g at negative x. Let's see what this gives us. Negative x times negative x times negative x. 3 negatives multiplied together would give me a negative. X times x times x would give me x cubed. Now, positive x divided by negative x, that's like saying positive 1 divided by negative x. That's like saying negative 1 divided by positive x. And notice what happens here. If I factored a negative 1 out of both of these terms, this is what I would be left with. Negative x cubed divided by negative 1 gives me positive x cubed. Negative 1 over x divided by negative 1 gives me positive 1 over x. And now I think you might be able to see that g at negative x is equal to negative 1 times g at x. Look at x cubed plus 1 over x. That's what g at x is. So since g at negative x equals negative 1 times g at x, we would say that this function is odd. Basically, what you're looking for is the signs to change. So if this went from positive x cubed to negative x cubed, that's a sign change. If this went from 1 over x to negative 1 over x, that's a sign change. Both terms change signs, that means it's odd. If this one changed and this one didn't, that wouldn't be odd. It would be neither. It's not even or odd. Okay, if it stays the same, it's even. If its signs change, all of the signs change from positive to negative or negative to positive, then you have what's called an odd function. Okay, and I believe that's how you do question 2 on your worksheet. And that's the end of that little video. You guys can go to work. If you have any questions, you can message me in Teams. Oh, I guess there's one last thing. This function odd or even? Okay, a lot of people think it's odd because they think they grab this and they rotate it and then fall on top of that. Problem is, that's not the origin. This is neither even or odd. Okay, and just to prove that, look at this, f at 1.8. If I go 1.8 units to the right, I'm up 4. 1, 2, 3, 4. F at negative 1.8 is 1.8. Okay, it doesn't equal 4, and it doesn't equal negative 4. It's not f. I can't say this. F at x equals, sorry, f at negative x doesn't equal f at x, or f at negative x doesn't equal negative 1 times f of x. In order for this to be true, this answer would have to say 4. In order for it to be odd, this answer would have to say negative 4. It doesn't say either of those. Okay? Therefore, it's neither odd or even. So go to work on your sheet.